and greetings everyone. Welcome to my final year project presentation. I'm Nurfatin Najihah binti Roslan, a final year student in Bachelor of Science Honours, Applied Chemistry. The title of my thesis is the effect of solvent on modified platinum TiO2 in degrading reactive red for dye. I'm supervised by my lecturer Dr. Wan Izanawawi bin Wan Ismail. So, this is my presentation outline. Firstly, I will briefly explain about my research, followed by methodology, result and discussion, and conclusion, also recommendation. Now, let's get started. Nowadays, the industrialization, mining, and urbanization are the human activities that contribute to global environmental pollution. Organic pollutants such as organic coloring dyes in the textile industry are getting increased and difficult to degrade due to the toxicity and stable molecular structure. So, there is three types of wastewater treatment technique, which is physical technique, biological technique, and chemical technique. In this study, we will be focusing on the chemical technique. Chemical techniques such as photocatalysis, ion exchange, electrocoagulation, solvent extraction, and many more. And I choose photocatalysis as an alternative to degrade the pollutant. So, what is photocatalysis? Photocatalysis is a process that can remove contaminant at ambient temperature and pressure by oxidation, according to Yahya in 2018, when light energy irradiated from sun or any other sources to facilitate the chemical reaction. Photocatalysts create strong oxidation agent and electronic holes to break down the organic compound. In this study, we use titanium dioxide semiconductor, where it will absorb UV radiation from sunlight to produce pairs of electron and holes. Electron of valence band become excited when illuminated by the light. Excess energy of this excited electron promoted the electron to the conduction band, and in this stage, hole is created at the valence band. Hence, oxidation and reduction process occurs simultaneously and convert organic compound to more stable compound, which is water and carbon dioxide. This cycle continues when light is available. So, why titanium dioxide semiconductor? It is because titanium dioxide is a low cost, abundance, high stability, high photocatalytic, and low toxicity. However, it has some limitation as it has high band gap energy, in which it is require high energy of light to photoactivation to occurs, and it also have high tendency of electron hole recombination. That's why we think by modifying it with metal platinum is the best alternative to increase photocatalytic degradation of dye chosen. Let's take a look on the problem statement. Less photocatalytic activity of titanium dioxide due to high recombination stage. Thus, according to Sun in 2022, in order to improve the photocatalytic performance, changing the electronic structure of the semiconductor to adjust the structural is most effective method. The objective of this study is to prepare the modified platinum TiO2 photocatalyst by using photodeposition method applied under different solvent effect. Secondly, to determine the optimum condition platinum TiO2 at various solvent with photocatalytic efficiency under photocatalytic degradation of reactive red for dye. Lastly, to determine the effect of modified platinum TiO2 and the chemical reaction between platinum and TiO2 with various solvent effect. Now, let's move to the methodology. Firstly, we have to prepare the platinum TiO2 by using photodeposition method. To prepare the platinum TiO2, photodeposition method was carried out by using 0.25 titanium dioxide that mixed with isopropyl alcohol, distilled water, and hexachloroplatinic acid hydrate that be used as platinum precursor. This solution then put into the Schlenk tube, as can be seen in the figure, and the magnetic bar inside being put and closed tightly. The vacuum was used a few seconds alternately with nitrogen blow for 1 minute, and this step was repeated 3 times. This step was repeated to prevent oxidation by remove the oxygen gas. All the sample then was used for the photodegradation of RR4 dye to determine its efficiency. Photodegradation was run under 55 watt light irradiation, then the dye was used for UV analysis by measuring the absorbance. For the result and discussion, characterization of platinum TiO2 with different solvent was undergone by using X-ray diffraction (SRD), Fourier transform infrared (FTIR) spectroscopy, and inductively coupled plasma mass spectroscopy (ICP-OES). As can be seen in figure, all solvent-prepared photocatalysts show the intensive and broadband at 400 to 1000 indicate the strong stretching vibration of titanium and oxygen bond. A broad peak was also appeared at 3000 to 3800, result from absorption between hydroxide group and water. Since washing process was performed, the platinum TiO2 has easily attract and absorb the water molecules. Next one is X-ray diffraction. In all the analyzed sample, anatase peak appeared at 25.8, 39, 48, and 56.8 degrees were detected. Reflection peaks demonstrate that all the sample made up primarily of the anatase phase with some rutile phase as well. However, no diffraction peak of platinum is found, possibly due to the extremely low content of Pt incorporated with titanium dioxide. The actual percentage and amount of platinum was measured by ICP-OES. The percentage obtained was very low, which can be due to the various steps and batch taken during the photodeposition photocatalyst preparation. In that, sample was heterogeneously prepared, where it is compulsory to prepare by only one batch for all the sample-based platinum TiO2. Dichloromethane and acetone solvent prepared have quite similar percentage of platinum with acetone, but comparable to the polarity, dichloromethane has the higher polarity than the acetone. Hence, OH group absorption is higher and increase the vibrational frequency of the metal and OH. Next, let's move to the photodegradation study. Photocatalytic performance of PT-TiO2 under different solvent effect under suspension mode are shown in the figure. The absorbance is decreased continuously with the increase of irradiation time. All samples have shown to have photocatalytic degradation under RR4 dye with more than 80% to become colorless in 20 minutes under light irradiation. It can be observed that the dichloromethane prepared photocatalyst has the highest percentage of decrement in suspension compared to the other solvent prepared photocatalyst, which only took 5 minutes to degrade more than 80% of RR4 dye. The modification of platinum with titanium dioxide by using hexachloroplatinic acid hexahydrate as precursor has successfully been prepared under photodeposition method. Under light irradiation, by using different of solvent to study the effect of photocatalytic performance, the higher photodegradation rate of RR4 dye was obtained by dichloromethane prepared solvent, which 0.3072 minutes. It is proven that low polarity lead to high performance. As a suggestion for the next research, this study should carry out with more characterization to prove the result obtained during the experiment. Sample analysis can be run using FSM EDX to determine morphological difference on the surface shape and identify the presence of platinum on the surface metal. Besides that, the characterization that can be made is photoluminescence analysis to identify and determine the EH recombination stage that can bring significant impact on this study.